I am Dr. Basir-Ahamed-Khan, Assistant Professor of Physics, Krishnath College. This is lecture 3 of module 10. In my previous lecture, that means in lecture 1 and in lecture 2 of module 10, I discussed on Maxwell's velocity distribution law and the graph of Maxwell's velocity distribution, different expression of velocity, that means root mean square velocity, most probable velocity, and the average velocity of gas molecules. And in lecture 2 I discuss on degrees of freedom, law of equipartition of energy, and the specific heats of gas. Now today I will discuss on these three topics. First one is mean free path, second one is collision probability or survival equation, and last one is estimates of mean free path. Now the first one is mean free path. The definition of mean free path. What is mean free path? Definition. Mean free path, lambda is represented by the term lambda. The molecules of a gas move at random in course of their motion. They collide to each other. That means the molecules of a gas move at random in every direction and collide with each other. Between two collision, a molecule moves in a straight line path. That means between two collision of two gas molecules, they move in a straight line path. This path between two collision is called free path. The mean or average value of free path of a molecule is called mean free path. So I repeat the definition of mean free path. How can I explain the mean free path? That means suppose a gas molecule move at randoms in any direction, collide with on another molecules and moves any direction, and again collide with another molecule and moves in this direction. So in this direction again collide with molecules, then it moves in this direction. That means a gas molecules move at random in every direction and collide with another molecules. So and between two collision, the gas molecules move in a straight line path, and this path between two collision is called free path. That means this is a free path, this is an free path, this is a free path, this is free path, this is also free path, this is also free path, and these are straight line path. The mean or average value of free path of a molecule is called mean free path. That means if I measure the distance of the path and take mean, then we get the mean free path. That means I say again, now what is mean free path? That first of all, what is free path? That two gas molecules collide each other, and between two collision, the gas molecules moves in a straight line path, and this path is called free path. If we take the average or mean of the free path, then this average or mean free path is called mean free path. That means mean free path, the mean or average value of free path. Mean or average value of free path. Mean or average value of free path. These are the free path. Suppose these path, these are the free path. This path, and so on. This path is called free path, and the mean or average value of free path is called mean free path. Mean free path. This is called mean free path. Now the probability, we calculate the probability px, we calculate the probability px that a distance x that a distance x be the free path of a gas, be the free path of gas molecules, that is gas molecules, that is molecules, that is survival equation. This is survival equation. I want to find the condition of probability that a distance x be the free path of gas molecules. Suppose the probability that a molecule does not suffer collision in a distance x is px or fx. What is fx? The probability that a molecule does not suffer a collision in a distance x. This is the probability which is a function of x. Probability that is function of x. It represents the probability represents the probability that a molecule does not suffer collision in a distance x, that a molecule does not suffer collision in a distance x, mind that this is the probability that a molecule does not suffer collision, that means does not suffer collision in a distance x. This is the px, and it is obvious that this probability must depend upon x. That's why I write px equal to function of x. This is the function of x, that is function of x. It should be the function of x. that is that is the function of x. It is the function of x. That's why I write px equal to fx. Now the probability of crossing a distance x plus dx without any collision, x plus dx equal to function of x plus dx. It also it represents the probability of crossing a distance x plus dx without any collision. Probability of crossing a distance x plus dx without any collision. Crossing a distance x plus dx without any collision. Without any collision. This is the probability px plus dx, the crossing a distance x plus dx without any collision. This is the probability of crossing a distance x plus dx without any collision. This is the function of x plus dx. That's why I write px plus dx equal to function of x plus dx and px equal to function of x. Now if lambda be the mean free path, mind that if lambda be the mean free path, if lambda is the mean free path, then probability of occurring a collision in the path dx is dx by lambda. If lambda is the mean free path, then probability of occurring a collision in the path dx is dx by lambda. This is the probability of occurring a collision in the path dx. So this is the dx by lambda. So the probability of no collision in a path dx is, this is the occurring a collision in the path dx, in the path dx. This is the value dx by lambda, occurring a collision in the path dx. This is dx by lambda. So the probability of no collision in the path dx, so probability of no collision in a path dx is equal to 1 minus dx by lambda. I repeat again the point. If lambda be the mean free path, then probability of occurring a collision in the path dx is dx by lambda. This is the probability of occurring a collision in the path dx by lambda. So probability of no collision in a path dx equal to 1 minus x by lambda. Thus the probability of describing a distance x plus dx without any collision is, thus the probability of describing a distance of describing a distance describing a distance describing a distance x plus dx without any collision without any collision without any collision is equal to x plus dx px plus dx equal to px into px is the probability of no collision in a path x. This is px into 1 minus dx by lambda, or this is or px plus dx means f of x plus dx equal to fx into 1 minus x by lambda, 1 minus dx by lambda, 1 minus dx by lambda. This is equation 1. This is equation 1. So f of x function of x plus dx is the probability of no collision in a distance x plus dx equal to fx probability of no collision fx in a distance x, and again probability of no collision within distance dx equal to 1 minus dx by lambda. Therefore f of x plus dx equal to fx into 1 minus dx by lambda. Now using the mathematical rule of Taylor's theorem, using Taylor's theorem f of x plus dx equal to, we know that fx plus dx into f prime x means dfx dx almost equal to fx into 1 minus dx by lambda. We expand the left hand side fx plus dx into Taylor series and then equate with fx into 1 minus dx by lambda. Here I neglect the higher order terms or higher order powers of dx because dx is small. Since dx is small, we neglect higher order terms. Higher order terms of dx. As dx is small. Therefore, we get fx f prime x by fx equal to minus 1 by lambda. f prime x means dfx dx. We get from this relation we get fx f prime x by fx equal to minus 1 by lambda. So now integrate this equation. We get integrating this equation we get integrating this equation or integrating we get now integrating we get integrating this we get integrating we get ln means log base e ln fx equal to minus x by lambda plus ln a. ln a is a constant or a is a constant where a is integrating constant. A is a constant. A is a constant. A is a constant. A is a constant. Or ln fx by a equal to minus x by lambda. That is, or fx equal to fx equal to fx equal to a e to the power minus x by lambda. That is, we get fx equal to a e to the power minus x by lambda. This is equation 2 where a is a constant and lambda is a mean free path. Now to find the constant a, we remember that at x equal to 0 fx equal to 1. At x equal to 0, now at x equal to 0 fx equal to 1. What is fx? Fx means px, the probability of no collision. That means at x equal to 0, probability of no collision is maximum, that is fx equal to 1. Therefore, from this, so from equation 2 we get 1 equal to a e to the power minus 0. That means a equal to 1. Or from equation 2 we get fx equal to e to the power minus x by lambda. This is equation 3. This is equation 3. This gives the law of distribution of free path or collision probability. This gives the law of distribution of free path. 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 Law of distribution of free path or collision probability. Collision collision probability. Collision probability. Now suppose the total number of molecules at x equal to 0 be n0 and the number of molecules arriving at a distance x without suffering collision be n. Suppose number of molecules at x equal to 0 be n0. n0 be the number of gas molecules at x0, x equal to 0, and the number of molecules arriving at a distance x without suffering collision be n. N is the number of gas molecules arriving at x without no collision. Therefore we write Px equal to Fx equal to n by n0. This is equation 4. N is the number of gas molecules at x equal to 0 and n0 is the number of gas molecules at x equal to 0 and n be the number of gas molecules arriving at x without no collision. That means probability Px equal to n by n0. Then from equation 4 and from equation 3 we get n by n0 equal to n by n0 from equation 4 and 3. From equation 4 and 3 we get n by n0 equal to e to the power minus x by lambda, or n equal to n0 e to the power minus x by lambda. This is also the form of survival equation for the molecules of a gas of mean path lambda. This is the number of gas molecules traveling a distance x without collision equal to n, which is equal to n0 e to the power minus x by lambda. Okay, so if I plot this equation, here is n and this is x, and this is n, and this is x, and this is x. If I plot this equation, then I will get at x equal to 0 it is n0. That means at x equal to 0 it is n0, and this becomes decaying exponentially. That means That means, and for x equal to lambda, then it becomes x equal to lambda, n equal to n0 divided by e. That means when x equal to lambda, n0 divided by e. That means at x equal to lambda, the value is n0 divided by e. This is the n0 by e. This is the survival equation, or the expression of existing number of gas molecules which are traveling at a distance x without no collision. Now the next point is estimation of mean free path. Estimation of mean free path. Mean free path estimation. Estimation of mean free path. Estimation of mean free path. Mean free path. Estimation of mean free path. Here suppose that only one molecule of a gas is moving with average velocity c bar. Suppose that only one molecule of a gas is moving with average velocity c bar. Only one molecule moves with velocity c bar. Velocity of molecule, one molecule equal to c bar. We consider only one molecule. We consider only one molecule. We consider only one molecule. And the velocity of this molecule equal to c bar. And the other molecule are rest. I repeat again, to estimate of mean free path of molecule, we consider only one molecule are moving with velocity c bar and other molecule are rest. Each molecule may be supposed to be rigid sphere of diameter sigma. A molecule of diameter sigma. That means here a molecule of diameter sigma. That means the radius equal to sigma by 2. The diameter of the molecule is sigma, and therefore the radius of the molecule is sigma by 2. Suppose another molecule collide with this molecule. That means these two molecules collide with each other when the distance between their centers becomes sigma. That means suppose another molecule collide with this molecule. Here is also the radius is sigma by 2. Same molecule. That means this is first molecule, this is second molecule. When another molecule, that means the second molecule, collide with the first molecule 1, when or under this particular condition, the distance between two center of the molecule will be sigma. This is very interesting. The center of the molecule, center to center distance of these two molecules will be sigma. That means here I write sigma is the diameter of molecule. Diameter of a molecule. Diameter of a molecule. That means sigma by 2 is the radius. Sigma by 2 is the radius. So one molecule collide with other molecule, and at this particular time when they collide with each other, the distance between two gas molecule will be or will be sigma. The distance between two gas molecule will be sigma. That is, we can say that that one molecule collide with other molecule when the distance between two center will be sigma. That means if I draw a sphere of radius sigma, if I draw a sphere of radius sigma, this sphere is very interesting because the collision possible only when one molecule comes to the sphere of this, comes in just on the comes, and their center will be on the sphere of radius sigma. I repeat again, the dotted line in this figure show a sphere of radius sigma, which is a sphere of influence of the moving molecule. So this is the black color molecule. The black color molecule is a moving molecule of radius sigma by 2, and this is the dotted line indicates a sphere of radius sigma. The other molecule collide with this moving molecule only when the other molecule center will lie on the sphere of the dotted line sphere. Otherwise no collision occurs. That means collision will occur only when the center of other molecule will lie the sphere of influence, lie on the sphere of influence. This is called sphere of influence. Sphere of influence. The sphere of influence. What is the significance of sphere of influence? When the center of any other molecule lies on this sphere, what is the significance of sphere of influence? When the center of any other molecule, when the center of any other molecule, lies on this sphere, it will collide it will collide the moving molecule, moving molecule, moving molecule. Moving molecule means the molecule which is moving. That means here in the figure the black sphere is a moving molecule. So the black sphere, that means this molecule collide with another molecule only when the center of other molecule will lie on the sphere of influence. It is obvious. So the moving molecule, that means the sphere of influence of the moving molecule traverse a cylinder of radius sigma and length c bar per second. Here is interesting. This is moving, this is the black molecule, and here is the sphere of influence. Sphere of influence. It is moving in this direction. It is moving in this direction. That means this moving molecule produce a sphere, produce a cylinder of length c bar in 1 second, in 1 second, in 1 second. That means it produce a cylinder, it produce a cylinder, it produce a cylinder of length c bar in 1 second. That as the velocity of molecule is c bar. So this is the molecule, this is the molecule, and this is the sphere of influence. This is the sphere of influence. These moving molecules produces a cylinder of, produces means just I assume this sphere produce means here I assume a cylinder of length c bar in 1 second, and the molecules which are lying in this sphere, these molecules are colliding with the moving black molecule. In this figure I color in the black color. So the volume of the cylinder is the volume of the cylinder of length c bar is volume of cylinder is equal to pi sigma square. Sigma is the radius of sphere, that means sphere of influence, and c bar, this is the volume of the cylinder. Now if n be the molecular density, then the number of molecules within the cylinder is, if n be the number molecular density, then the number of molecules be the molecular density, that means number of molecules per unit volume, be the molecular density. The number of molecules within the cylinder is the number of molecules within the cylinder, is within the cylinder is equal to n into pi sigma square c bar. N into pi sigma square c bar. This is the number of molecules lying in this within the cylinder. So the moving molecule makes this number of collision per second. So the free path becomes, this is important, this is the number of molecules within the cylinder, where n is the molecular density, and this is the number of molecules lying on the cylinder. So it is obvious that this number of collision occurs within 1 second at a distance c bar. That means we can write pi sigma square n pi sigma square c bar. Number of collision occurs, number of collision occurs at a distance, equal to c bar. So one collision occurs at a distance equal to c bar divided by n pi sigma square c bar, and this is mean free path, therefore mean free path lambda equal to c bar divided by n pi sigma square c bar, that is lambda equal to 1 by pi n sigma square. This is the theoretical value, and the correct expression for lambda, this is the expression or estimation of mean free path theoretically, but practically the experimental value of lambda is experimental value equal to 1 by root 2 into pi n sigma square. This is the experimental value of mean free path. Only one root 2 time root 2 factor is extra in experimental value, and this is the theoretical value of mean free path, and this is the theoretical value of mean free path lambda equal to 1 by pi n sigma square.